So good afternoon, students. So in the previous session, we have been discussing about sort of deep learning concepts. So what is actually deep learning and how the neural network architectures can be built, and what are all the different architectures that we used to see and we used to have for solving a different kind of problems. So using the different kinds of data sets, right? So majority we have been using the complex data like images or the videos or the text or the sequential data. So we have been working on that kind of data sets. Okay, so since in the previous session we have seen so how to process, how to predict or identify using the sequential data. So just a bit deeper with that concept. So we are getting into the new topic completely from the new perspective. Okay, so which is actually called as NLP. Okay, so what is NLP? Okay, so NLP is actually a natural language processing, which is a technique so that we used to have, okay, for processing the natural language, human language. Okay, so how the human is used to communicate with other persons or with the even in using the different devices. So how human used to communicate, human used to express. So in order to understand that kind of language, it can be of any language, it can be of any language like English, Kannada, Hindi, Portuguese, French, like anyways. Okay, so the machine has to understand that, and it has to interpret, and it has to generate the human language, right? So for such kind of things we used to have the a technique called as NLP, which is natural language processing. So natural language processing helps the computers to understand and also to interpret and to generate the human language. It can, like you might have used that chat GPT and all, right? So what you are observing, so you used to ask the questions, it is to give the answers. So it's not mandatory that you are not using the formal questions, right? So you used to like, hey dude, come on, do this like this, can you please do it? So it's like I'm feeling so boring, I'm feeling so happy today, right? So it used to respond to those kind of questions. It used to respond to those kind of feelings actually, right? So how it is understanding it, so what you are saying, what is the emotion behind that thing that you are asking, right? So or what you're saying, so it is going to understand that, and it is going to it's going to interpret, and also it is going to generate the response, right? It is not the there is no such specific output for this statement like that, right? So there are no such things are there. So it like for the same question, if you ask multiple times in multiple different situations, so it will ask you, it will respond you with the different answers, right? So it is just getting the context, understanding it, and for that, according to your mood, your emotion, or your requirement, it is going to respond, right? So such kind of things, how is being happening there. So those things need what is called as natural language processing, how the human is going to communicate. So that human language has to be understood by the machine, and it has to interpret, and it has to respond to those language that they are using, right? So the study of these things, how the human language is going to understand, how it is going to be interpreted, and how it is going to be generated. So study of these things is all included in this natural language processing, NLP. Okay, so it studies the language as the data, and develops a model so that can analyze that linguistic structure actually. Okay, so what are the language, what is the language means for this word. So it is going to understand the language structure, and it is going to understand the meaning, and it is going to understand the context in both the written and spoken communication. So that means it is going to understand the text and the audio data. Okay, so speech data. So it is going to analyze, it will want to collect and understand, analyze, and interpret, and then generate or produce. Okay, so this is how that NLP is going to, so this is what actually NLP is doing. Okay, so now let us see, so what are all the different steps in this domain we are going to do. Okay, so in the NLP pipeline, so we used to follow these steps for before actual processing. Okay, so before actually understanding and predicting the or generating the language or text or audio text or the speech output, so it needs some sort of things to be done. Okay, so the language, which can be in the spoken or like typing words, written words, or the it can be a spoken words, so that has to be pre-processed, and then it has to be interpreted, then it has to be used for the next predictions or any future generation purpose. Okay, so this is what the NLP pipeline that we used to have more often. Okay, so before feeding before applying any AI or any ML technique. Okay, so first thing it is raw text. From the raw text we are going to clean it. Okay, so first we are going to clean the data, and next we are going to tokenize it. Okay, so what is the text cleaning is means like whatever the data you are speaking, so whatever the information that you are speaking or you are typing, so or you have written information, so those things may contain the special symbols like at, hash, or dots and percentages, and so these are the symbols which used to call as the special symbols, and these things will be removed, handled, or at least. Okay, because at some cases we used to use these special symbols, like for expressions we used to see these symbols like exclamatory marks and question marks, full stops. So okay, these are the symbols that making the difference of the different statements. Like, so question marks makes the statement as a question, not as a just as a plain statement. Exclamatory mark adds the feeling like excitement or like that, and full stop like plain expression. So likewise, so we are going to handle this. Apart from this, we are going to have the other special symbols at hash, so till quotes, likewise. So we used to remove all those stuffs which is not needed, and whatever the HTML codings are there, some data will contain these things, so we have to remove all those stuffs. And for a uniformity and for a simple processing, simplicity of the processing, so we are going to convert the mix of uppercase and lowercase characters to all in the lowercase characters. Okay, so lowercasing, we are going to do some lowercasing, and then afterwards, so what we are going to do, so after all these steps we got to know this, so the text will all be cleaned. Okay, so we got removed from the dust, we dust it off. Okay, and next it is after this thing, so we are going to do some tokenization. So what is actually tokenizations? So tokenization is nothing but we used to have like whenever you are communicating like a language or the communication means, so what it contains actually a sequence of words, right? It's a collection of statements, right? So in the tokenization step, so what we are going to do, so we are going to split up sentences if you are giving the lengthy paragraphs or kind of stuffs. So we are going to split up the sentences, and we are going to split up the words. Okay, so in order to process it. Okay, so you have like which problem we are solving, so based on that, so we used to choose the action. Okay, so if you want to split the sentence, then you can go for sentence tokenization, and if you are using only the very few sentences are there, so then you can go for word tokenization. Okay, so both are available in the library, so then you can just use them by using a function call. Okay, so and after tokenization, why this is needed? So in order to pre-process it, in order to use them each in order to understand the meaning of each and every word which is present in the text data or in the speech data, so we are going to do this for tokenization. Okay, and after this, so what happens? So next thing we have to do for stop word removal. Okay, so what happens in this step? So in the case of stop word removal, so whatever the unimportant words are there, so everything will be removed. Okay, so whatever the unimportant words are there, and whatever the helping words type of things, and the words which are not contributing much on predicting or understanding the things, so those are all removed from the text data, like whatever the raw input that you are going to give, you are going to use. So from those information, everything like which is not important, so those things will be removed. Okay. And after that, so what happens? So that is what your stop word removal. Okay. So the words like a, the, is, and, so some preposition type of things, or some articles type of words, so those things will be removed. Okay. And after this, what happens? So we often go for doing stemming. Okay, stemming, what it means? So in the stemming stage, so we are going to find out the root word of the current word. Okay, it like in the paragraphs means we might have used the words like running. We might have used the words like playing, stacked, tired, right? So tiredlessness, useless. So likewise type of words, right? So what this will do, so in this step, so it will going to reduce the complexity of the text data or the speech data. So how? So it will going to find out the root word actually. Okay, so what is the root word? For example, so if we have the words like running, okay, or run, right? So the root word will be run. Okay, so run is the main keyword or the root word. So this is just the extensions according to the situations, right? So it will going to find out the root word and take out that converted word. Okay, so whatever the words are present in the after this stop word removal step, so whatever the words are present, so in all those words it will going to find out the root word, and I will just, so it will just take out the root word from those set. Okay, and then, so after this, what it will happen? So it will going to find out the features from this data, right? So how this is going to extract the features? So like how frequently the particular word has been appeared, so how often it is appeared, so which are the words that is appeared, or what is the meaning of it. Okay, so likewise, so whatever the features and so on, so whatever the other features are there, so those features will be extracted by using the built-in methods which is available in the libraries. Okay, so and by using a specific techniques, okay, word text processing techniques, or else the embedding techniques we used to say. Okay, so these kind of things going to happen whenever you are going to do any NLP task. Okay. Excuse me. Excuse me. Okay, so these are the steps we often go for using the NLPs. Okay, then let us see just the implementation of these steps, so one after the other. Okay, so key task that we often do now is for the tokenization. We are going to use the technique called word tokenization, as I said. So we can go for splitting up the words, each words, and we can go for splitting up the sentences as per the requirement. Okay, and we can use the next word is stop removal. Okay. So stop words removal, you can go for stop words. So there's a library support. Okay, so you can go for that. And next, lemmatization. So lemmatization is nothing but finding out the root words. Stemming and lemmatization, finding out the root words. So both of these are doing the same thing, but one is using but using the different approaches. Okay, and pause tagging. It is a parts of speech tagging. Okay, so parts of speech tagging in the sense, so it will going to identify whatever the words which are coming after this finding out the root words. So stemming or lemmatization, so whatever the words list of words we used to get, so all those words will be like what kind of parts of speech is being for that word. Okay, so each and word is being a part of any speech, right? So what kind of grammar thing it is. Okay, so that thing will be helpful for understanding the context. Okay, for that purpose, so this is also be done. For next thing it is, we are going to convert. This is the next step. So we're going to extract the features, thereby we're going to convert the text data into a numerical data. For that, the popular approaches or popular techniques are like a bag of words or TF-IDF techniques. Okay, so these are the things. So both are used for converting text data into a numerical data. Okay, so both will be converted, so like that. Okay, and first we shall go with, okay, first we shall go for tokenization, how it's going to happen. Okay, so let us just implement it. Okay, so tokenization. So for this things, what it will do, so for tokenization, so it will going to identify where the spaces are there. Okay, so where the spaces are present, where the full stops are, special characters are present. So it will just going to identify those stuffs. Okay, and then so it will going to split up wherever it is appearing those things. So ಎಲ್ಲೆಲ್ಲದು ಕಾಣಿಸ್ತಾ ಇದೆ, ಸೊ ಅದನ್ನು ಅದು ಐಡೆಂಟಿಫೈ ಮಾಡಿಕೊಂಡು ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಪ್ಲಿಟ್ ಅಪ್. ಓಕೆ, ಸೊ we have two techniques over here. One is word tokenize, another one is sentence tokenize. So for word tokenize, what it will do, it will just scan the entire input. Okay, so it will just going to scan the entire input. So while it is scanning, so wherever the space has been appeared, okay, if the space appeared, it will just make a break over there and it will just split up the next thing to a different word. Okay, for example, so if I have the statement like hello world, how are you? Okay, so if I have a word like this, just a sec. Okay, so I have like if I have the word like statements like this, so what it will do, it will going to keep on scanning. So for the first round, so what it will do, so it will going to scan HELLO. Okay, it's after this, so the space immediately appeared, right? So after this, what it will do, so it will just split up hello as one word and rest of these things as one word. Okay, so now one word is separated. Next, it will going to continue to scan. So matte scan ಮಾಡಿ continue ಮಾಡುತ್ತೆ. So after this, so space will come. Okay, so what it will do, it will just split up this separately. Now it has 3. Okay, next, continue to scan. How? After this, space comes, so it will just split this thing from this and going to split up this. Similarly, this. Okay, so finally this will be having 1, 2, and even for the special symbols also it is getting differentiate. For if the symbol is not an alphabet character, so it will go to split up that also as a word. Okay, but in case of sentence, it is not going to be identified. Okay, so full stop and question marks both are identified as a different words. Okay, now 1, 2, 3, 4, 5, 6, 7. So these are the word list elements which comes after word tokenize. So in the same fashion, if you use the sentence tokenize, so wherever it is seeing the full stops, it will just split up. Okay, so that's it. So that is how it is going to work out. Okay, so let us just see the implementation of this. Okay, now so for this thing, so we are going to use the library called as NLTK. Okay, just check out for whether this library is present in your system or not. So if not, just use the pip commands to install the library. Okay, so now it is already installed. We'll just need to import. So from NLTK dot tokenize import. So we have two different techniques. One is word tokenize, and we can also go for sentence tokenize. Okay, so this is the libraries that we want. Okay, now let us have a data, so text data. Okay, so I said hello world, how are you? Okay, now need to call this function. So I'll just have the word, so word underscore tokenize. So what is the data? It is text. Variable is present in text. Just run this. See. So this is how it is split. We have different elements, different words as a different elements in the list. Okay, so likewise it is going to split up. Okay, so similarly we can go for sentence tokenize. So here also we want to feed the data. See here. So since the two sentences are there, so two elements. Okay, so likewise, so this will going to differentiate, split up the sentences. Okay. Okay. So if you have the lengthy statements or a book of things, so then like whatever the intention is there, so which kind of problem you are solving, like if you are using the sentiment analysis or if you are using the overall overview of a particular book or article, so then you can just simply go for sentence tokenize. So but you are using the prediction things or auto complete type of things, then you have to go for word tokenize. Okay, so this is how the tokenization going to happen. Okay, these are all the pre-processing steps we often do. So whenever you are doing the NLPs, so whenever you are working on the natural languages, okay, so if you are creating any chatbots type of things using any AI techniques, so then you can simply go for this. Okay, so next thing it is, so this is tokenization. So next thing it is, what is it? Stop word removal, so which is present in the corpus. So how the stop words will be removed. Okay, I'll just print this once. Next it is stop words removal. So how the stop words will be removed. So we have been using the different libraries. Okay, so similar to this. Excuse me. Okay, so we have been using the separate library, like very similar to this tokenizer. Okay, so ಈ tokenizer ಯಾವ ಥರ ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅದೇ ಥರ library support ಇದೆ, so that also can be used. So there what happens actually, okay, so there, so in the case of stop word removal, is it going to identify so which is the stop word. Okay, so it will filter out the commonly occurring words like so the and is or in a likewise. So it will like just because they provide like a little bit nothing in presenting the semantic analysis or text analysis, right? So it will just provide no or very little bit of semantic value or the to the text analysis. So that's why we often go for removing these kind of stuffs. So these words are known as stop words usually. Okay, so like these stop words may include like articles, so preposition type of things or pronouns like of things. So the and is and were like of stuffs. Okay, so while they seem insignificant, so that's why, so a proper stop word handling can dramatically impact the performance of the accuracies actually. Okay, so that's why we often go for removing these type of stuffs. Okay, so how we can remove this? Okay, you can just need to go for using the library. Okay, so the library here is, so from nltk dot corpus import stop words. Okay, so here in this, so we need to import the nltk modules, and after this, so we have to download the required sources like stop word data. Okay, so because we have been like human language in this sense, it is not to restricted to a particular language, right? So it can be of different language, as I said before. So we can use the different languages. As per our language, we have to use the stop words. Okay, so here I am taking the English. Okay, stop words. First we need to download the stop word list from the library. Okay, so nltk dot download of stop words. Okay, and so this is what we have to do. So, and my text is about, so this is a simple sentence for NLP using for stop word removal. Okay, so just have to stop. Okay, so just now what I need to do, so I need to pass this. Okay, so I need to first get the stop word list from the library. Okay, so I'll have stop underscore words. So I have the different name for this. So I have stop words dot words of, so I have used English. Okay, so this is my set. Now I just want iದೇನು ಮಾಡುತ್ತೆ, so it will just create a list of stop words, English stop words. Okay, so then, so what we need to do here is, so we need to compare this list with the words in this. Okay, so before comparing this with this, what we need to do, so we need to tokenize this. Okay, how we are going to tokenize, because we need to split up the words and check out each and every word whether it is a stop word or not. Okay, so just have word tokenize of text data. So it is tokens is equal to, then we need to compare this. Okay, so my tokens are this, so we have the list of words, and my stop words for the particular English language is this. Okay, we have plenty of words here. Okay, so these are all will be checked for in our data. Okay, so now what we need to do, we just need to remove all those from our final data that we are going to use for any predictions or any advanced feature purposes. Okay, so what we are going to do, so we're going to have the loop. So for word in tokens, so we're going to have the empty list. Okay, so it is filter data anta togote. Okay, so filter data or filter text. Okay, this is equal to empty list. So after this, what we need to do, so if what is it, if that word present in the tokens is not in stop words. Okay, andre ಸೊ ನಮ್ಮದು ಏನು ಲಿಸ್ಟ್ ಬಂದಿದೆ ಅಲ್ವಾ, ಸೊ ಅಂದರೆ ಇಲ್ಲಿರುವಂಥ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ವರ್ಡ್ನ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಆ್ಯಂಡ್ ಇಫ್ ದಟ್ ವರ್ಡ್ ಈಸ್ ನಾಟ್ ಪ್ರೆಸೆಂಟ್ ದಿಸ್ ಲಿಸ್ಟ್, ದೆನ್ ದಟ್ ಈಸ್ ನಾಟ್ ಅ ಸ್ಟಾಪ್ ವರ್ಡ್. So that is a word which have with some meaning. So then keep that. If that word is present in the stop words list, then just don't try to add that. Okay. So that is what we are checking. So here we are using membership operator, that not in the sense the words which are not present in this stop words list. So use just keep those words only. So that is where it is removing the stop words. Okay, stop words, filtered text dot append of, so what is that word? Okay, so then finally needs me to print filtered text here it is. I can observe here. Okay, I can observe here this simple sentence NLP using stop word removal. Okay, here we can see is removed, a is removed, for is removed, here for is also removed, right? So whatever the final text, so that is present here. Okay, so this is how we can remove the stop words. Okay, so what is that original data and what is that previous data? Okay, so here you can see original is what this, and filtered token is this. Okay, so this is how we can remove the stop words. Okay, so next what it is, so we are going to have stemming. So what is actually stemming? So stemming is what you are finding out the root things. Okay, so finding out the root words in the sense, whatever the words are there, so which are present with few tenses, like future tenses or the past tenses, or with the present continuous, so like kind of stuff. So we're going to find out the root word. Okay, so that itself is called as a stemming in this NLP. So stemming is an important text processing technique, so which reduce the words to the base or the root form. Okay, so by just removing what it will do, so it will just remove the prefix or suffix which is appended to that particular word. Okay, so this process actually what it is doing, it will going to standardize the words, which help to improve the efficiency of the particular model, NLP model. NLP task ಏನು ಮಾಡ್ತೀವಿ, ಸೊ ಅದರಿಂದ ಎಫಿಷಿಯೆಂಟ್ ಆಗಿ ರಿಸಲ್ಟ್ ಬರಲಿ, ಲೈಕ್ ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಐಡೆಂಟಿಫೈ ದ ಕೋರ್ ಮೀನಿಂಗ್ ಆಫ್ ದ ವರ್ಡ್ಸ್ ಆ್ಯಂಡ್ ದೆನ್ ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಇಟ್ ಫಾರ್ ದ ಎನಿ NLP task. Okay, so stemming what it will do, it will just simplifies the words to the most basic and most root format, so making it very easy to analyze and process the text. Okay, so for example, if I have the running, if I have chocolates, okay, so it will be like, it will become like run, it will become like chocolate. So if I have retrieval, so it will become like retrieve. If I have happily, it will become happily. And it will be, if you have usefulness, so it will get uselessness, or usefulness, it will become useful. So likewise, so this is how that stemming is going to happen. So thereby it is going to reduce the complexity in order to understand the context meaning of the language. Okay, so how it can be done? So after this filtered text, so we have just going step on steps. Okay, so after this step, so we can just go for using that stemming option. Okay, so how stemming going to implemented? For this we are going to import the library called Porter Stemmer, okay, which is present in the NLTK library again. So from nltk.stem. Okay, So we need to call the object post stemmer. So it can be any name. Okay, I'm just taking the same name. Okay, so we need to create an object. Okay, so these are filter text is what are words. Okay, so I'll just have it. I'll just extend this quite a little bit. So I am I'm just having a random statement, so don't go for meaning of it. Okay, so I'll just run this. Okay, so here we have just got pages. Okay, so now I just need to apply this. So stemmed words. So again, similar to the previous steps, we are going to have the empty step. Okay, so instead of not, so we're going to check out. Okay, so for this also we are going to have the list of words. Okay, so those things we can go for using the root words. Okay, just have it. So instead of filtered text, we have stemmed words. Word is present in filter text. Just having an underscore mistake. Okay, so the for word in, so the words to be present in this filtered text. Just a second, just say it. Okay, so what it has to do, it has to find out the words stemmer function with stem of particular word. So what is that? A word na find out ಮಾಡ್ಕೊಂಡು stemming ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. Okay, so I'll just find out that word. So which is used to setting x, so which is x. Just a sec. So Porter's tomatoes actually. Okay, we need just a sec. Okay, so I can go for this. So whatever the words are there, so everything will be find it out with the root words. Okay, so here, so after this filter text, everything has been removed with the stop words, and we have got to know what is the root word. So what's the filter text? So for filter text, so we're going to check out for each word and find out the root word for this. So it is present in the Porter stemmer, so in that library. So this thing we can go for this. Okay, so and you can observe here, it will just cut off the ending words, ending few cut off words. So and it will just keep out the previous ones. Okay, so for using, so the word is use. For running, so word is run. Okay, for tired, it is tire. For remove, for stop words, so it is stop word. So likewise, so it will going to convert. Okay, so that is how this stemming going to work out. Okay, so we're going to completely changes the root, whatever the words are there, and taken it back to the root format. Okay, so after this thing, so what we are going to do, so we have to go for converting these things into a numerical format. Okay, so after porting and stemming, lemmatization, so before that we have to go for POS tagging. So POS tagging in the sense, so we are going to tag, attach the parts of speech of that particular words, which parts of speech it is belonging. So we are just taking that thing and attaching it with the each and every word. Okay, so that we are going to do. Okay, so by using POS tagging in the sense parts of speech tagging. So parts of speech tagging, it will going to it will going to attach, so which part of this parts of speech it is belonging. So just like adjective, so just like noun, word, so whatever is there, right? So it will going to find out all those things and just get to know what kind of which part of speech is presenting by this word. So thereby it helps the programmer to understand the meaning of the word actually. Okay, so that is why it often yes. Yes, please. So anybody have any doubts? Is anybody is having any doubts, any questions? Okay, fine. So that is where you are finding the meaning, extracting the meaning of the particular text data. Okay, so can you mute yourself? Someone is silent. Okay. Okay. So parts of speech tagging, so that we do it. So it is a fundamental task in the NLP actually. So where whatever the words are present after these steps, so each word in the sentence is assigned with the grammatical category. Okay, so grammatical category in the sense which is known as like nouns, verb, adjective, adverb, preposition, conjunction. So like type of strips are there, right? So that will be tagged with those each and every word in the sequence. Okay, and this process helps the machine to understand so what is the structure and what's the meaning of the sentence by identifying the roles of each and every word and their relationships. Okay, so connections, how frequently it is appearing, what is the previous word, what is the next word. So it is going to understand that things, thereby it is going to get the context and it is going to use that for future predictions or autocomplete type of things. Okay, so that kind of things going to happen in this step. Okay, how this is going to do? So it's in a very simple way. So it will just use the library support. So it will take up the library called as pos underscore tag. So from nltk dot from nltk import pos underscore tag. Okay, so here it is going to use pos underscore tag of, so what kind of data we are using? Stemmed words. So here we can see, so the adjectives are tagging here, parts of speech is tagging here. So this is a noun, simple is a noun, sentence is a noun, NLP is a noun, commas is comma, exactly, special symbols are keep it as it is, use is a noun, stop word is a noun, remove is a noun, so I is a adjective, and run is a verb, storage is a helping verb, and got is a verb, and tired is also noun. Okay, so that thereby it is going to find out which parts of speech it is actually, and first it is going to install the necessary resources, and it is going to apply the POS tagging. POS tagging is parts of speech tagging. So first we store the sentence and tokenize it in words, so using the word tokenize. So then we are going to apply that POS tagging, so to the tokenized words. Okay, so here we can also apply it for after stemming stage also. Okay, so just apply on the tokenized words. So after this, just simply tokenize. So we have tokens. Okay, so we can just give it like this. Okay, for each and every word you can see here verb, so adjective, adverb, noun. So you can just see here, right? So this is what type of thing. So it will going to display the words along with the tagged grammatical category. Okay, so why this is used? For text simplification and for improved search and for named entity recognitions. So this is going to be used, making the POS tagging can break down the complex sentence into simpler parts, and thereby making them easier to understand. So that is why we often go for this, going to do this. So and as it also improves the information retrieval by categorizing the words and making it easier to search the text, okay, while you are in the browsing. Okay, so that is why this is often used, and in case of identifying the names or identifying the places, or like when you're searching for a particular type of stuffs, right? So these kind of tagging will having the it's a role major. Okay, so in recognizing the role of the words in a sentence. Okay, so that is where you see the important role of this POS tagging. Okay, so and after this, what we need to do after stop word removal? So we have a POS tagging. So after this, so we are now at one stage of pre-processing, natural language pre-processing. So now it's time to convert. So what we used to do it in machine learning. So often after doing every pre-processing steps, the final step we are going to do some conversions. Encoding type of things, converting the text data into a numerical data. So here also we often go for this thing, converting this words text data to the categorical information to the numerical information. So sorry, I just so like whatever the alphabets are present are converted to the numerical data. So for that purpose we can go for one hot encoding. So we often do it, right? So we often go for label encoding, one hot encoding and all. So here we can use the specific techniques. Even that encoding techniques can also be used. So but efficiently, if you want to do it efficiently, preserving the meaning of the words, so then just go for using this bag of words or TF-IDF techniques. So these are the techniques so which will be used for
converting that text data into a numerical. Okay, so because machine requires the numerical input, right? So the text must be converted into a numbers, which is also called as vectors. Okay, so these kind of techniques what you are seeing, like bag of words or term, TF-IDF, term frequency, inverse document frequency models. So these are called as the text representation techniques. We have n-gram language modeling, we have LSA, we have LDA, we have encoding. So type of different techniques are also there, but most commonly and used techniques are bag of words and frequency and inverse document frequency, TF-IDF techniques. Okay, so these are very useful at the standard. Okay, and which will give you the efficient results also. Okay, so let us discuss these text representation techniques and the text embedding techniques. So and using these information after pre-processing in order to predict something to perform any NLP task. So we shall discuss all these stuffs in the next sessions. Okay, so just practice on these stuffs. So we shall discuss this bag of words and TF-IDF and word embeddings in the next sessions. Okay, so hope the concepts are clear. So if you have any doubts, you can just ask me.